So the next question is limit n approaches to infinity 1 power p plus 2 power p plus 3 power p and so on plus up to n power p upon n power p plus 1 is equal to dash. So denominator is which is in the form of a power m plus n. Now I am changing this one as n power p into n. Now limit n approaches to infinity, this denominator n I am writing here 1 by n into, now this 1 power p divided by n power p, we can also write 1 by n whole power p plus similarly 2 power p upon n power p, we can also write 2 by n whole power p, similarly 3 by n whole power p plus and so on n by n whole power p. So now limit n approaches to infinity 1 by n I am writing as it is. Then this series 1 by n whole power p plus 2 by n whole power p and so on up to n by n whole power p, we can also write summation r equal to 1 to n r by n whole power p. So this series we can also write summation r equal to 1 to n, summation r equal to 1 to n r by n whole power p. Suppose if we can take r is equal to 1, we get 1 by n whole power p. Suppose if we can take r is equal to 2, we get 2 by n whole power p and so on. If we can take suppose r is equal to n, then we get n by n whole power p. So now how we can solve this? So we have one formula, limit n approaches to infinity 1 by n summation r equal to 1 to k times of n f of r by n, which is equal to limit n approaches to infinity 1 by n into summation r equal to 1 to k times of n f of r by n. We can also write integration of 0 to k f of x dx. So by using this property we are going to solve this problem. So how this limit summation become a integration? This limit n approaches to infinity, limit n approaches to infinity summation we can replace with the integration, and this 1 by n we can replace with dx, and r by n we can replace with x, r by n we can replace with x, then it become f of x. Here we have f of r by n, then it become a f of x. And if r is equal to 1 to k times of n, then we can change it as the limits 0 to k. 0 is the lower limit, k is the upper limit. So here coefficient of n is 1, so the value of k also 1. So then it become a integration of 0 to 1 x power p dx. R by n we can replace with x, 1 by n we can replace with dx, r by n whole power p. So as it is x power p. Then limit n approaches to infinity summation we can change it as integration, and r equal to 1 to n, coefficient of n is 1, so the value of k is 1. So then we get integration of 0 to 1 x power p dx, integration of 0 to 1 x power p dx, which is equal to x power p plus 1 upon p plus 1, 0 to 1. Integration of x power p is x power p plus 1 upon p plus 1, lower limit is 0, upper limit is 1. So after substituting the limits we get 1 divided by p plus 1. So correct answer is 1 by p plus 1. So next problem is integration of minus pi to pi 2x into 1 plus sin x upon 1 plus cos square x dx is equal to dash. So now I am splitting this integral as integration of minus pi to pi 2x upon 1 plus cos square x dx plus integration of minus pi to pi 2x into sin x upon 1 plus cos square x dx. So now we have some important properties here. Integration of minus a to a f of x dx, which is equal to 0 if f of x is odd function, which is equal to 2 times of integration of 0 to a f of x dx if f of x is the even function. Integration of minus a to a f of x dx is equal to 0 if f of x is odd function, which is equal to 2 times of integration of 0 to a f of x dx if f of x is a even function. So now I am going to use this property here. So if we can observe this 2x by 1 plus cos square x, so this entire thing is a odd function, so it becomes 0. So this entire part becomes 0. So how we can say whether the function is a even function or it is a odd function? Now f of minus x is equal to f of x. F of minus x is equal to f of x, then it is a even function, which is equal to minus of f of x, then it is a odd function. F of minus x is equal to f of x, then it is a even function, which is equal to minus f of x now, then it is a odd function. So now this first one is 2x by 1 plus cos square x is the odd function, so this entire thing becomes 0. And this 2x sin x upon 1 plus cos square x is a even function. Even function. So then how we can write this 2x sin x by 1 plus cos square x now? So 2 I am taking outside the integral. So we have the formula 2 times of integration of 0 to f of x dx. So then it become 4 times of integration of 0 to pi x sin x upon 1 plus cos square x. I am taking this entire integral as I. So let I is equal to 4 times of integration of 0 to pi x into sin x upon 1 plus cos square x dx. So now I am going to use another property here, which is integration of 0 to a f of x dx is equal to, we can also write integration of 0 to a f of a minus x dx. Integration of 0 to a f of x dx, we can also write integration of 0 to a f of a minus x dx. Now which is equal to 4 times of integration of 0 to pi. So in the place of x we can replace with pi minus x. Why? Because a value is pi, a minus x. So here we need to substitute pi minus x. Then sin pi minus x, which is the sin x. Sin pi minus x, second quadrant, sin is positive, we get sin x upon 1 plus cos pi minus x is the minus cos x. Anyhow we have square here, then it become a plus. So denominator as it is 1 plus cos square x dx. So I am taking this is equation number 1 and this is equation number 2. Now I am adding 1 plus 2. Left side and right side I am adding 1 plus 2. Then I plus I it become 2i, which is equal to 4 times of integration of 0 to pi into sin x upon 1 plus cos square x dx we will get. So how we will get this step now? 4 times of integration of 0 to pi x into sin x upon 1 plus cos square x dx. Now if we can split this integral, integration of 0 to pi into sin x upon 1 plus cos square x minus x into sin x upon 1 plus cos square x. Pi into sin x upon 1 plus cos square x minus x into sin x upon 1 plus cos square x. Then this plus term and negative term gets cancelled. Then finally we get 4 times of integration of 0 to pi into sin x upon 1 plus cos square x dx. So now I am taking here let cos x is equal to t, then it become minus sin x into dx, which is equal to dt. So minus sin x into dx is equal to dt. Now if we can substitute here, 2i is equal to 4 into integration of limits cos 0 1, if we can substitute pi minus 1, then pi into sin x dx is dt, minus dt. So minus I am writing here minus 4 times of integration of 1 to minus 1 pi into dt upon 1 plus t square. So I am going to simplify this. 2i, which is equal to minus 4 pi tan inverse of t with the limits 1 to minus 1, then 2i which is equal to minus 4 pi into minus pi by 4 minus pi by 4 we will get. Then I is equal to, we should cancel here, minus 2 pi into minus 2 pi by 4. Then we should cancel everything, we get finally pi square. So pi square is the correct answer.